Hello. So this is Chapter 3, Section 4, Contingency Tables. Before we get into this problem here, I want to point out, if you look at the section for Chapter 3, Section 4, it's almost nothing but examples. So I'm going to do this example for this video, work through it with me, and then I really do encourage you to sit through the section and just try some. Right? There's not really anything to read as much as just try problems. So try a few of them. The best way to understand something is to wrestle with it yourself, right? So we have a contingency table. This is also sometimes called a two-way table. So if you look at this, what we have is two variables, right? And we think about the data, is it quantitative data or qualitative data? It's qualitative, it's categorical, right? It's along the top whether or not somebody in the study had a speeding violation. So yes, speeding violation or no speeding violation. Those are categories. And then along the side here, we have uses cell phone or does not use cell phone. That's a categorical variable. Now, we are counting how many are in each category to make this two-way table. So if you're reading this, what does this 25 number mean? It means that in the study, there were 25 people who used cell phones while driving and had a speeding violation in the last year. What would this be? That's people who use a cell phone while driving but had no speeding violation last year. Okay. Now, what's this? The 305. Yeah, it is everybody who uses a cell phone, whether it is speeding violation or no speeding violation. Notice that if you do 25 plus 280, you get 305. So if we add up everything in this row, we get the total here. Same thing here. If we add 45 plus 405, we get 450. And going down the other way, 25 plus 45 is 70. 280 plus 405 is 685. And then 70 plus 685 is 755, and that should match 305 plus 450. So 755 is the total amount of people in the study. Now we can use this two-way table to calculate probabilities. So first one, find P of driver is a cell phone user. So the probability that a driver is a cell phone user based on this study. Okay, where's the total amount of cell phone users? Well, that's this row right here. And they're split into speeding ticket or no speeding ticket, but the total is 305. Now, is the probability 305? No, remember, probability has to be between 0 and 1. We want the total number of cell phone users out of the total amount of people in our study. So this should be 305, the total amount of people using a cell phone, out of 755, the number of people in the study. And you can convert that to a decimal if you like, to get a probability. Let me see. 305 divided by 755, I get 0.4. Rounding to the tenths place, I get, the hundreds place, I get 0.40. Okay, so what's the probability that a driver uses their cell phone while driving? 40%, based on this study. B, find P, driver had no violation in the last year. Okay, where's the total for no violation? This is the column for no violation, whether they use a cell phone or not. This is if they do use a cell phone. This is if they don't use a cell phone. But we want all of those, right? It's just no violation. So that's 685 is the total that didn't have a violation. So we have 685 out of 755. I'm not going to convert that to a decimal. You're free to do so if you want to see. C. Haha. Find the probability that a driver had no violation and also was a cell phone user. Okay, so we need two categories now, right? It's not just a single row or a single column. It is both. We're locking into a particular cell value. So when I say cell, I mean like if you were to think about this as a spreadsheet. Each of these little boxes is a cell, right? So we want no violation. So I'm going to erase so no violation is this column, and was a cell phone user, that's the first row. So that would be this cell right here. And again, we want to compare it to the total. So out of the 755 people in the study, 280 of them had no violation and used their cell phone. So there's the probability for that. D, find the driver is a cell phone user or driver had no violation in the last year. Okay, now this one is a little bit trickier. So driver is a cell phone user. How many is that? Well, driver is a cell phone user is all of these, right? So it's both the 25 and 280, which adds up to 305. And or, remember, is the union. So we put stuff together, and it's driver had a violation in the last year. So that would be all of these. Now notice if I do that, I end up counting the 25 twice, right? We've double counted some people. That's no good. So let's make sure that we do it correctly. Oops, sorry. Let's make sure we do it correctly. What did I choose instead? I chose a yes violation. I'm supposed to have no violation. Oops. Sorry about that. So we want this one. Then, so that means we're going to be double counting the 280, which is no good, right? I should. So if we think about probability of cell phone, so yes cell, plus probability of no violation, we have to subtract the probability of cell and violation because we'd be double counting it. In particular, if you have the probability of A or B, it's the probability of A plus the probability of B minus the probability of A and B, because otherwise we end up, let me write that with and, not the intersection symbol. Otherwise we end up double counting something. Sorry, my headphone fell out. So probability of a cell phone user, that is 305 out of 755, plus no violation is 685 out of 755, but we have to subtract the overlap, so 280 out of 755. And what is that? Oops. 305 plus 685 minus 280, 710. So we have 710 out of 755. And of course, I was able to add up all of those numerators directly because all of the denominators were the same, right? Can't add or subtract fractions without a common denominator. Luckily for us, we already had a common denominator. Okay, E. Find the probability that a driver is a cell phone user given that the driver had a violation in the last year. So far, for all of these problems, we've been using the total amount in the study as our denominator, right? We're comparing the frequency of a certain category to the everybody in the study, right? All 755 people. With this given, we're restricting where we're looking. So if it's given that the driver had a violation, that means we're only looking at the 70 people in the study who had a violation in the last year. Of those 70 people, how many of them are cell phone users? 25. So E is 25 out of 70. Okay, last one. Find the probability that a driver had no violation given that the driver was not a cell phone user. So we need to restrict to not using a cell phone, this row. So we're only looking at the 450 people in the study who do not use a cell phone. And then we want to know what's the probability of those 450 that they had no violation. Well, that would be 405. So we would have 405 out of 450. Okay, now, what can we do with this? right? We're able to compare and look at or make inferences about the relationship between two variables by looking at these kind of things, right? Like, hey, if you don't use your cell phone while driving, look at your probability of not having a speed violation. Well, that's 405 out of 450. That's what? It's pretty good, right? 405 out of 450. Oops. 405 divided by 450. 90%, right? So if you don't use your cell phone while driving, of all the people in the study, there's a 90% chance that you won't have a speeding violation. Pretty good, right? All right. Again, like I said at the beginning of the video, this section is almost entirely examples, right? It's just a bunch of contingency tables. Try them, right? Just do one. Um, in another video, I will do another example where we can fill in some pieces. Okay, I'll see you next time.